Welcome back! In the last video, we successfully set up our environment and even ran our first Java program, the classic Hello World. Now, you might be wondering what happens behind the scenes when you run a Java program. How does the computer actually understand and execute our code? That's exactly what we'll be exploring in this video. Understanding the fundamental concepts of how Java works will give you a deeper appreciation for the language and help you troubleshoot issues more effectively down the line. Let's start by understanding three key components in the Java ecosystem: the JVM, the JRE, and the JDK. At the heart of Java's functionality is the Java Virtual Machine, or JVM. Think of the JVM as a special virtual computer that lives inside your actual computer. The JVM is responsible for executing the compiled Java code, making Java platform independent. This means you can write your Java code once and run it on different operating systems like Windows, macOS, or Linux, as long as they have a compatible JVM, of course. Next, we have the Java Runtime Environment, or JRE. The JRE provides the necessary resources to run Java applications. It includes the JVM, along with libraries and other files that are needed for Java programs to execute correctly. Think of the JRE as the complete operating environment needed to run a Java application. It's the minimum requirement for running Java programs. Finally, we have the Java Development Kit, or JDK. This is what we installed in the previous video. The JDK is a superset of the JRE. It contains everything in the JRE plus development tools needed to create and compile Java programs. This includes the Java compiler, JavaC, which we'll talk about in a moment, and other utilities for debugging and managing Java applications. So, to summarize, the JDK includes the JRE, and the JRE includes the JVM. Last time we installed JDK because we want to create Java programs. Now, let's walk through the steps involved in taking the Java code you write and actually running it on your computer. First, you write your Java code in a plain text file with a .java extension. This is called the source code. This is the code that we humans can understand, like the code that we've seen last time. The processor inside your computer, however, does not understand this directly. It needs to be translated into a language it can understand. This is where the Java compiler JavaC comes in. The JavaC compiler, which is part of JDK, takes your .java source code file as input and translates it into a bytecode. Bytecode is an intermediate language that is platform independent. It's stored in a file with a .class extension. Developers usually do not work with the bytecode directly. Java bytecode is not specific to any particular operating system, unlike many other programming languages. Next, to run your program, the JVM comes into play. The JVM takes the .class bytecode file and interprets it, converting it into machine code that your specific computer processor can understand and execute. Because the bytecode is platform independent and the JVM is platform specific, the same .class file can run on any operating system with a compatible JVM. So, let's imagine you made a Java program and want to share it with your friend. What options do you have? You can send your friend a source code, your file with .java extension. Then your friend will need to install a JDK first, to compile the code, and then to run it, because as you remember, the JavaC compiler is a part of a JDK. Alternatively, you as a developer can compile your program on your computer and send your friend a compiled version of your code, which has .class extension. In this case, your friend only needs to install a JRE to run your program, or if they have a JDK, it will also work, because the JDK has a JRE inside it. Let's quickly recap the key takeaways from this video. The JVM is the virtual machine that executes Java bytecode, providing platform independence. The JRE provides the environment to run Java applications, including the JVM. The JDK is the complete development kit for Java, including the JRE and development tools like compiler. Java code is compiled from .java files into .class files containing bytecode. The JVM interprets the bytecode and executes the program on your specific operating system. So the process is write code, compile with JavaC, run with JVM. And actually, when we hit that green triangle in the IDE, it made the exact same steps. compile it first, and then run the compiled version. It just combines these two steps into a single action. Understanding these fundamental concepts of how Java works will be incredibly helpful as you continue your programming journey. In the next video, we will finally start digging into the actual Java code, breaking down the Hello World program line by line. If you found this explanation helpful, please give this video a like, and if you have any questions about the JVM, JDK or JRE, don't hesitate to ask them in the comments below. Make sure you're subscribed so you don't miss the next video where we will get our hands dirty with the actual Java syntax. Thanks for watching and happy coding!